specifically I want to talk about, yes, there's another acronym on the board already. It's GWERM. It's the Great Western Route Modernisation Project. It's specifically about a railway, and I'll talk more about it. But it's not just what we're doing on the project right now. It is a live project. But it's also how we're adopting these workflows on all different types of projects that we work on as well. So this is just an example. So to give you a bit of context, it's all about this man for a lot of our railways in the UK. So Isambard Kingdom Brunel. He really did set the standard, didn't he? Back in about, the 1850s, he basically endeavoured and designed things that people just thought, that is impossible, that's crazy. And he did that, utilising the technology of the time. But now, we need to modernise again. It's that next era. And now we're looking at electrifying this very historical, old asset to make it more efficient, more modern, clean, faster. But it's not just about the infrastructure we're creating. It's about the data, the information behind that, to make that smart, integrated as well. So where is this railway that you keep speaking about, Luke? Right, well, specifically, the Great Western Line stretches from London to Cardiff. And specifically what I'm going to be sharing with you today is the work that we're doing between Bristol and Cardiff. It's quite a complex area, and I'll be honest, if we're looking at electrifying. We're working with a number of key partners. So Network Rail, the main operator in the UK of rail, we're working heavily with, as well as our partners ABC, as well as Tata Steel, who are also one of our designers, as well as Arup as well. There's lots of things going on here, and you might notice you're electrifying this, Luke. It goes under some water. Sounds complicated. It is complicated. It is complicated. It needs a lot of data. There's 3 cities, Bristol, Newport and Cardiff. Lots of complex structures as well that are going on here. So what's the problem? I should have warned. This talk I did a few weeks ago in Capturing Reality, and I know some of you will be disappointed. I've taken all the sound and music references out and replaced them with Dutch local examples, good metaphors. So what's the problem, Luke? Well, the problem is there's lots and lots of data. Like if you go to a shop, probably in Amsterdam, there's lots and lots of clogs here. Different shapes, different colours, different sizes. You could almost be confused by the amount that you've got here. And also, engineers, they're a funny old breed. They're used to a clog in their own size. In fact, they may not be aware of this brand new clog as well, state of the art. So we need to work out how this data and this information works. It's also using some of the principles about how you approach data. So this is kind of coined as well from Richard Saul-Wurman, the creator of TED, and he talked about latch. So you categorize data by location, alphabetical, temporal, categorical, and hierarchy. You need to traverse these because it depends what you're looking at if that data is right for you. So you connect this data, and it's a bit like a bike in some ways. Another very subtle metaphor. And behind this, we've got our design, our overhead line equipment, electrifying equipment, which is the driver. It's almost like the pedals that drives this design forward. But it needs to be connected to something, otherwise it won't go forward. You need to connect other disciplines. You need to connect environmentalists. You need to connect planners. You need to connect different councils. You need to connect basically everyone. what to do with it, including citizens. If you don't, it's not a bike and it won't go anywhere. So how would you do that? Well, from a data point of view, when we started this particular project, I sat down with Network Rail, and there was no EIR, Employees Information Requirement, which sets out what they need. So we worked with Network Rail to go, what is it that you actually need? How are you actually going to use this as an asset management point of view? What's the deliverable? So we generated this document. It's a BIM execution plan. But actually, it's more about data and information management plan. It's not just CAD, it's not just GIS, it's how you use information full stop on that project. From formats of data, where the data is coordinated, what the coordinate systems are, what the document naming references are, to make things accessible. So that's a plan. But what does it look like? Well, there's also another thing called the Common Data Environment, CDE to its friends, or foes. And I think this was a useful diagram that we generated as part of this. And it goes through the workflow that we use on this project. Now, the aim would be to have one box that rules them all, and you can traverse throughout your life cycle, so going from work in progress to shared to published to Network Rail, for all data. Unfortunately, the practicalities of that are a little bit tricky. Commercial and technological as well. So you can see that we've got these three compartments. We've got an area for our CAD data, another one for our documents, and then, oh jangles, we added a third one. Tabular and spatial data. This has been really important in using the power of databases to actually store huge amounts of data, but also be able to flip the way that we view that data and relate that data in live time. At the moment, we're in discussions about how we actually hand this over to Network Rail, which is why you see there is a big blank space. But that's something we're going on for. So you've got this common data environment, Luke. This looks okay, but how do you actually access it? Well, oh great, you've got ProjectWise over there. That's great. You've got a platform which is built on business collaborators called ABCnet, and you've got a database. Whoa, there's a lot of restrictions here, Luke. First of all, if I don't know CAD, I'm not going to be able to open up one of those files. I might not even have Word. What about if I've got this ABC net? I've got the same issues. How do I look at this? And as for a database, I'm going to have to be a programmer to work out head and the tail of this. So it's not just about how you store data and collect data, but it's how you access that data. Otherwise, it's kind of pointless. So, data accessibility is one thing that we've been really championing on this project, because without it, you don't have this connectivity of that bike that I showed you. And a big thing of that is things like HTML5, for instance, as well as things like 3.js, open formats, and so that they can use it on whatever device they've got. So what does that look like? Well, we've got a project web viewer. And as you can see, this is just a website. It's built on some of the ArcGIS JavaScript API. And I've got lots of data. Some of this data was actually just caught up in spreadsheets, actually. But they're able to actually connect to that data, some of these through FME, for instance, and view that data spatially. And then they can click on that data to view the attributes. And then they can also look at it as a spreadsheet if they also want to look at that. You can also click on it and identify it. So going back to those latch principles that I was talking about, you can approach it from any angle. It's what's right for you. You can then add further context and some of those more basic things, as well as doing measurements. It's just a web browser, essentially. And then you can also search for assets as well. That's quite critical when people start referring to assets as different names. So we've geocoded all of those. And we also found that all engineers absolutely love Google Street View. But without the context of their data, it was kind of, I think that's where the asset is that I'm designing to this mill. So yeah, we integrated that into it. But that's kind of what you've got now. How do you integrate that with the current data that we're capturing? We have a whole lot of LiDAR. We've got close to 3 terabytes right now, and that is increasing. It's a huge amount, huge. And we've integrated this into the web platform. You can see some of the extents here. And as I click on it, you can see kind of how far these are. Some of these have been collected previously on the project. And we can zoom in and just go, well, actually, where is this data? Before I start deep diving into that point cloud, I need a bit more of that context, as it were. So you can do that, and you can start looking. You can also then click right to project-wise. So if you're then the design team and need that in a CAD environment, boy, you've got it. You've got it. You can go straight to it, use it in the package. But then you can use it in the web browser. Now, there's a massive shout out that I've got to do to Potry that enable this. Look it up, it's on GitHub. But we've integrated this with the point cloud data, then with our GIS-based data that you saw in the web viewer, which is really critical. So you could see there, this is the asset, this is the chainage. Okay, this is what I can do. You're not creating new data, but you're viewing that data. Now this one is a big one. This one is for Severn Tunnel. Huge data set, it's about 1.5 terabytes. It was collected by Severn Partnership, actually, only fairly recently. Now, if you loaded this into a CAD environment, the traditional ones, such as Bentley MicroStation right now, and AutoCAD, it just won't be able to render all of it this quickly, all in one go. But you'll very easily be able to view that data with that context. And you can see the intensity here of the values and how the point density as well. Looking at individual brickwork. I've shown this to some of the asset managers, and they're using this now initially to understand, hey, this point cloud stuff that we're collecting on this design project looks quite useful. Better than my scribbled out map. So already this is going to prove to be a bit of a context, not just for our capital design delivery, but also for the actual future of that asset, and such a large asset as the Severn Tunnel. And then if we actually just then zip to Cardiff, so I can just, like I just did previously, I can just search for that and look at what information I've got here. Now I've got some further information as well that is available here for me. And if I just click then onto one of these locations, I can then see that I've actually got some train-based data. So this is where we use one of the Topcon machines actually, where we mounted that onto a train to actually view that information. And you can actually see passengers there. They almost look like Minecraft. So hopefully that could be something we could touch on further. And then do measurements as well, I should have said earlier as well. So straight away, they don't need actually any new software, but they're able to go, great, you've got this huge point cloud, or in fact, some of the board level of the program, we all say, what's this data that we've paid for? And then you can see some of the stuff that we've done from a vehicle as well, using our mobile mapping as well data. And it's all then just directly integrated back. So we've also then been going, great, we've got LiDAR data, but actually we need to fill in the gaps. So this is where we've been actually using Matterport. So it's basically built on 3 prime sense cameras, like the Microsoft Kinect. And for environments like Cardiff Central Station, we didn't need that survey grade data. But that camera enabled us to capture that information. It's the same process as well as Google's Project Tango as well, in the way that it uses SLAM to create 3D environments. It was just another source that we were very quickly be able to just go out and collect. Well, we've also got track view. Did I tell you? Engineers love Street View. Well, we still really love Street View. But what we did is, just using then the imagery that we did from the train LiDAR, we then just integrated that into this web platform as well. So we store over 20,000 individual bubbles that we can then just view and go straight away into it. And because it's a bubble, they can look anywhere as well. Really valuable throughout the entire track. We've also gone, actually, our engineers go on site, and they're still going to go on site. So we actually have a folder that is watched. And as soon as an engineer goes, I've got my iPhone or Android, and they drop down their photos, it's plonked onto a map. And they can view that spatially. Usually they just do a site visit and they type out, oh, I went to this site and here it is. But actually viewing it on the map enables us to actually engage with it on a spatial point of view. Well, Luke, you've talked a lot already about capturing that data. But how do you actually integrate that? I've not actually seen how you integrate that with your design. So the first one was, we actually saw that a lot of time was spent generating cross-sections. A designer just going, I just need a cross-section to look at the point cloud with my data at this location. Was just used because they didn't have the skills to get to that data. They didn't have specialist software. So what we did, we popped it all in a database environment, and then we just used some reporting services to just pull out all that data. So we've got one every 5 meters, and we can update this as the design updates as well. Huge resource. It's not technically a drawing, but it does mean that that data is accessible with some other data that they've got. We've got a lot then for 3D stuff for models. So for stations you can see we've got different point clouds going on here, but then it needs to build up into a full model. And previously, I think a lot of designers would have gone, we need a topo, or we need a 3D model. Thank you, we'll deliver that. But actually, as a resource, we have the responsibility to keep adding to that. It's never finished. So we have all these 3D data sets, like the Matterport one, the LiDAR, and we have topo, but we also actually found in one of the platforms there's a disused power generator under it, and you couldn't get to it. But we heard about this, we got some drawings, and we put that in. Really quite fundamental if you're then putting new foundations for masts. So the work never stops. And then we've also thought, well, this is great. You showed it in MicroStation there, Lee, but we need to make that on the web as well. So that's what we've done. And this is something that we are continually looking to develop right now. Like I say, it is a live project. We can see the extents of those models, and then you can click either onto the ProjectWise link, or you can click then onto just the view to view that just within that web environment. This is built on some of the City Engine ArcGIS API, that you can view that data, and most importantly, this is built to standards that we need to do so that we've got an IFC output and we've got attributes associated. It's not just dumb data. There's actual data behind it. It's not just geometry. So that's what we can do and that's what we can find. Then we've got another one. Once you've done your foundation, you have to do a trial bit. So we've done an app so that data is collected out on site. Previously it was done with just some paper and scribbled and then scanned in. We have an automatic email generated, and then we also have a web portal that you can see here that allows then the right people to view that data and edit that data as well. Look at those photographs. I know how hard this was without this system, and it was very painful. But this allows people to view that information as soon as they click send. They can view it back here, back in the office, and they can go ahead and edit it. Or they can generate a PDF on the fly using the SQL services as well, so that they've got that right there with them. All pulling from that live data. We also integrate that, as it's a database, into Excel. Sometimes you can't, you've got to work with people, and that's what we found. So we have here just a sheet which the designers update, but then we have the trial pit information that we had from site, then was checked. It's integrated directly into this spreadsheet. We use some VPNs to make all of this possible, but likewise it gives you a complete summary of what they need to do and what their progress is. And it's also integrated directly onto the web viewer as well, so that then they can actually see that data and actually go, is that right spatially? Viewing it from that other angle that I talked about. And that's been really, really useful and actually really important. And we're going to be doing this more and more as well. I mean, one data source, but looking at it from different angles. And like I say, that PDF needs to be stored as a full document control, and it is. It goes back to that common data environment I told you. You don't replicate data here, you link to that data, make sure it's up to date. Then we've done some other things to add further value to this data as well. So we have done things like check this with the Oculus Rift, and actually we did spot a few mistakes by some of the designers just walking around it. And then ultimately that same data we use for reviews and visualizations such as this. It's just a video, it's another way. So someone might go to me, look, this web view, it looks great, but actually I just need to look at it. It's the same data, then just in a video form. So then you get more of an appreciation of what the design looks like in context of our model, and then what it ultimately looks like with then trains on it. The key thing about this is making it accessible. It's got to be tidy, very much like Van Gogh's bedroom. You need to understand where things are. Right, that's the chair. Right, go and sit down on the chair. Right, and you need to have things so that people can find them. Without that, it's not accessible. There'll be a breakdown and potentially a delay in the program, particularly when we're already being looked at quite intensively by the media, by government at the moment. And making technology do the right thing for us, it's our actual time that we need to ensure that we make an opportunity at this and we're responsible, and empowering data to people is really important for that. Thank you.